Good morning, everybody. My name is James Cagle. Today we are going to be discussing file systems, and we are going to start with FAT, the File Allocation Table. This is used by Microsoft to index, locate, and store files on hard disks. This is the earliest file system used for hard disks by Microsoft. It has been in use since MS-DOS, and all of the current Microsoft operating systems still, in one form or another, still support this type of file system. The different forms of the FAT system are FAT, FAT12, FAT16, and FAT32. The number after FAT indicates the number of binary bits used to address blocks of data, or clusters, in the FAT table. The larger the number, the more distinct the address of the file. FAT limitations. It has a limited fault tolerance, insufficient storage. You can't just store huge files on FAT. You need the NTFS for that. And limited security. You're not able to really get permissions and encrypt the data. But despite its limitations, the FAT system does offer some benefits. It is supported by many legacy operating systems, which may be required if multi-boot situation is at hand. So like if you're like running Windows 7 and you have, say, DOS 3.0, you need FAT on there. That way you're able to work within it. Adequate technology that is well understood by industry professionals. Everybody knows what FAT is if you've been in the industry for a while. Then you've worked within it, and you know the file system. It is suitable for removable media such as memory cards for cameras, media players, and USB memory sticks. That's what everybody still uses on all those things. NTFS. The new technology was first introduced in Windows NT and is still supported by Windows 7. This is a more efficient and secure form of file system. NTFS partitions are theoretically limited to 256 terabytes, but the practical limit is lower. If you are using the IBM version, you will be restricted to 2 terabytes. Newer dynamic disk partitions are limited to 16 terabytes. One of the questions that I have for the class is it okay to transfer all files between two different operating systems using NTFS in both? So if you have NTFS on both your hard disks between the different computers, is it okay to transfer files back and forth if they're both using NTFS? I'll leave that up there for a second so you can copy it down. It is a fairly large question, so I'll give you some extra time. Okay, NTFS storage. NTFS stores files in a very similar way as a FAT file system. The difference is in how that data is secured, reliably managed, and allowed to grow. NTFS supports partitions above the 32 gigabytes imposed on FAT32. Some of the advantages of the new technology file system, which is what NTFS stands for. Let's see. It has a log file and checkpoint consistency checks, automatic bad cluster management, transactional NTFS, file names stored in Unicode and 8.3 DOS format, so it doesn't just have to be in the English language. You can use characters from all the different languages. Alternate data streams, encrypting file streams, folder and file permissions, which is the security part. Okay, some more is compression. You're able to compress the data. Disk quotas, shrinkable, expandable partitions and volumes, volume mount points, symbolic links, sparse files. We're going to discuss some of these at length here in a second. Okay, so now we're going to go ahead and talk about log file and checkpoint consistency checks. The FAT file system has little support validating that data stored to the FAT table is actually valid. Only the most basic form of error checking, using checksums and signature bytes, is typically performed. NTFS uses a more advanced system to incrementally update the directory information about files and folders stored in the NTFS portion. Information in the FAT table, it's actually stored in the MFT file, which stands for the master file table. This is something that you probably want to familiarize yourself with. Many different NTFS file systems are used to manage that data and features of a specific NTFS partition and volume. This is an improvement over the simplistic FAT table because a richer amount of detail and control structures can be implemented as virtual constructs for each file and folder, getting into the permissions. MFT is the most important NTFS file system file because it is a relational database that provides a starting point for accessing any file on the NTFS partition. So if you know how to access this file, which is a hard one to get into because it's like the $sign MFT, it's a hidden file. It's something that you probably really don't want to mess with because if you screw it up, you're going to screw up your whole file system. But you're able to manipulate and find stuff with it, so good luck. The automatic bad cluster management. That's one of the advantages of NTFS. This is an automatic feature built into NTFS file system. An NTFS system file called the bad cluster file keeps a record of all the clusters that are considered unusable by the file system within that volume. When the operating system detects a cluster cannot be trusted to store data, the cluster's identification will be automatically added to this file. If the bad cluster is currently used by a file or folder to store data, the operating system will try to move that data to a different cluster. The move is transparent to the user and does not require user intervention. So with the NTFS, you're able to, or your operating system is able to find that bad cluster on your disk and not put anything there. That's with FAT just put it wherever, and if it stayed, it stayed. If it didn't, didn't. Transactional NTFS. Transactional NTFS is similar to the transactional system used to protect NTFS file systems such as the $sign MFT. That's a master file table. But it is used in Windows 7 to protect file data. Updates using a transactional system utilize change logs and checkpoints to validate that updates have successfully completed. If there is a problem with the updates to a file, the changes can be displayed or rolled back to a good state. This is new to Windows 7. Actually, it started with Windows Vista. It's kind of neat. So if you have problems with something, you're able to roll it back to a previous version of a file. Good feature. Okay, so Unicode and 8.3 DOS. Basically, what this is for in the NTFS is that you're able to use any character that you want to name a file, and it doesn't have to be in the English-based ASCII 2 character set. So you can use anything from the Cyrillic language to the Jewish language, whatever. You're able to use different things. There are two file names to every file. One's a long file name, one's a short file name. The 8.3 DOS only allows up to 8 characters, so the computer automatically does that to be able to keep track of things. And using this system, you actually it goes up to like 300,000 different 8.3 aliases to coexist in the same directory. So that's quite a bit. And if you want to see the long file name and the short file name of a file, you type in, go to the CMD, start button, all programs, CMD, to get into the command line prompt, and then you type in the command direct/x, and it'll show you both file names. Kind of a neat little tidbit. Alternate data streams. A file stored on an NTFS file system can have multiple streams of data associated with it. Each stream is a sequence of data types. Every file has one unnamed stream that is used to store the byte data typically associated with the file and visible to users and applications. Files stored on the FAT system would only have the data associated with the unnamed section. Applications can create additional named streams and link them to the file in addition to the unnamed stream. This is the only visible and useful application itself, as the user does not have direct access to the name streams. Don't really know what that is, so I just kind of read it out of the book. You understand it more than me. We'll go ahead and give an example of that. A common example is a name stream that can be used to store a thumbnail of a large image for a quick and easy previews within a graphic application. The file name becomes a pointer to multiple related data streams instead of just one. So I guess it's kind of like that mouse over thing. Encryption. EFS, encrypting file system. Files that are stored on an NTFS file system can have their contents encrypted to protect the information from authorized users, unauthorized users that gain access to the file. Even though a user obtains access, they require additional security information to decrypt and access these file contents. The EFS is a part of the operating system that handles these operations. One thing to note is that if you encrypt a file and you try to transfer it to another computer, you're not going to be able to encrypt it there, because it's got to be done on the pretty much same computer that you did it on, because it has the information to unlock it. There is ways to transfer that information, but it's a little bit more in depth. So with the NTFS, you're actually able to give file and folder permissions. This list of permissions is known as the Access Control List, the ACLU. The ACL. It's kind of neat, because with the other ones you weren't able to say, well, this person can have access to it and this person can't. You can only have access to this much of the file, you know, as opposed to the whole file. It's new with the NTFS. It's a good little thing. We've gone over it in detail in other presentations, so that's pretty much all I'm going to say here. Compression. Files can be compressed to save space on the NTFS volumes. The compression process is transparent to the user and their applications from the user's perspective. The file takes up its uncompressed amount of space on the disk. When a compressed file is accessed, Windows 7 will decompress the file and present it to the user and their applications. When the file is closed, it recompresses it. Not all files should be compressed. Each time a file is compressed or uncompressed, the CPU performs the calculations required. This impacts a computer's performance by some extent. If many compressed files are being accessed, the impact to performance may be significant. It takes a lot of CPU ability to be able to compress and decompress a lot at the same time. Disk quotas. Disk quotas. This is a fairly important thing, especially for the 102 class for networking. Disk quota basically, you set it up through the disk management console, the MMC. Basically what it is that you can, for different users, you can say this guy can only use 2 gigabytes of space on the hard disk. This guy can have 15 gigabytes. This guy can have 10 megabytes. So it's a good little tool to be able to manage your disk space. Something you probably want to get familiar with. Shrinkable and expandable. Basically what this comes down to is that the partitions and volumes, whether you're using basic or dynamic disk layout, with the NTFS file system, they're expandable and contractible. They're able to grow, so you can make, if you set a partition to 2 gigabytes and you reach that limit, as long as you have the space, you're able to keep expanding them. So with with FAT table, once you set it for 2 gigabytes, that was it. You weren't able to change it. But one thing to note is that I don't think you can go from you can go from FAT to NTFS, but you can't go from NTFS to FAT. So once you choose that FAT, you're kind of stuck with it, or NTFS, I mean. So that's what that. Volume mount points. A partition or volume has a finite amount of space available. The partition or volume can be expanded or spanned, but in some cases this is not an option. Volume mount points allow an empty folder in an NTFS formatted file system to point to another partition or volume in the local computer. Volume mount points are also known as junction points and are created with a disk management console. The user performing the task must have administrative privileges on the computer. So basically what a volume mount point is, it's a folder that allows you to point to another partition, which, you know, to us it just looks like a folder, but to the computer it's telling it a whole different set of rules. So you can create a little mount point and you can go to it and you're able to access other partitions through that volume mount point. I'm not going to get into symbolic links very much because it's a pretty in-depth thing. Basically it was created for Windows 7 to be able to support a Unix-based POSIX application. So basically it's a folder that you point to in order to access another file, and that file does not have to be on your computer. It can be on some remote computer, on a server, on the web, or whatever. And it's not like it's not a shortcut file. It's a different kind of thing. It's probably something we won't use very often. Sparse files. A file can be stored with a special attribute to mark it as a sparse file. Large portions of a sparse file contain bytes with the value of 0. Instead of storing long strings of zeros, the sparse attribute tells NTFS to track the ranges of empty data. The sparse file will then contain non-zero data and a list that identifies where ranges of empty data occur between non-zero data. If a sparse file contains 50 megabytes of non-zero data and 200 megabytes of zero data, the file size will be just over 50 megabytes with a sparse attribute set. The same file copied to a fat partition would require 250 megabytes of disk space. So I guess maybe it's just a kind of like a compression thing. I really don't know. So that's pretty much all I'm going to say about it. Okay, everybody, that's my presentation. I hope you liked it. It's kind of about 3 o'clock in the morning. I had a long work day, so I hope this will work. Have a good day, everybody.